Question number 5 is transformation. So let me do a little bit of a review. The transformation for absolute value, modulus transformation. So modulus or absolute value, both are valid. Now for this particular transformation, what we have to do is, you have to, if you have a picture like this, and if this is fx, y equals to fx, and if you have to do the transformation y equals to absolute value of fx, it means you break down everything below the x-axis and bring it upwards. So that's what it means. It means reflection on the x-axis and bring it upwards. Anything below, you reflect it upwards, but if anything is upstairs, meaning above the x-axis, you keep it untouched, but if anything below the x-axis, you reflect it on the x-axis upwards. That's what it means. So let's do the first one. So for this sketch, so what we have to do, this original picture, you have to label it x-axis, y-axis and origin. This is very, very important. So this portion will be exactly the same. So this would be as it is. So you mark here Q, so this would be Q. Now what you have to do, you have to reflect this upwards. Now for reflection, remember, it has to be exactly like a reflection. If this is like this, the reflection should be like this. It has to be exactly like a reflection. So this is very, very important. So the reflection here would be like this, V-shaped, like this. So the reflection here would be like this, and this point here would be P. So this is the absolute value transformation, y equals to absolute value of fx. Now for B, this is the same C1 transformation that we are used to. Here we have the transformation a fx and later on fx. These transformations are called the stretching transformation. Afx means the picture will be the same, it will be stretched horizontally around this, it will be stretched vertically. So what you do, you multiply the y coordinate with a and the x remains unchanged. Here what you do is you divide the x coordinate with a. So that's what you have to remember. For this, it is stretching, and this is a different type of stretching. You're actually compressing, you're dividing with a. So here what we do, for this sketch, the trick is, you have to remember the picture will be more or less the same. So if you just draw the picture as it is, and all you do is change the y coordinate. Since it is 3fx, meaning afx, you multiply the y coordinate with a. So the y coordinate is q, so you multiply q with 3, so this would be 3q. So this is done, and the x will be unchanged. Now for the next transformation, f half x, you divide the x coordinate with half with a. So the x coordinate is p, so p divided by half is 2p. So this is what the transformation is going to be. Remember that. So this particular question is the modulus of a function. So we have to deal with this because it will be a transformation, usually absolute value of fx and then f absolute value of x, and then it is followed by solving. So in question number B, state the exact value of q. So this comes from fx equals to this. So fx equals to 3 ln 2x plus 3. So if you take a look at the picture, remember it's the continuation of this sum. If you take a look at this picture, so this is fx. So if fx equals to that, if you want to find the value of q means where does the picture cut the y-axis. So you write at y-axis x equals to 0. So you can write y equals to 3 ln 2 into 0 plus 3. That will be 3 ln 3. Therefore, this is the y coordinate where this has got the y axis. So q equals to 3 ln 3. That's it. Question number C, you have to find the value of p. So at x-axis, y equals to 0. If you remember the picture, p means it is cutting the x-axis. X-axis means y equal to 0. So this is going to be 3 ln 2x plus 3 equals to 0. The y coordinate is equals to 0. If you send the 3 to the other side, it becomes 0. So ln 2x plus 3 equals to 0. Now the formula for logarithm is, this is from the exponential function and logarithm chapter. So this is the formula. If you have ln x equals to a, it would be x equals to e to the power a, and the other formula e to the power x equals to b, then x equals to ln b. That's how it works. So here we have ln meaning logarithm natural, so you have to write therefore 2x plus 3, whatever is after ln, that thing is equals to e to the power this thing, which is 0. Now anything to the power 0 is 1, so 2x plus 3 equals to 1, so 2x equals to minus 2, therefore x equals to minus 1. So this is the value of x, meaning this is where it cuts the x-axis. So wherever it cuts the x-axis, that is the value of p, so therefore p equals to minus 1. The final question is, you have to find the equation of the tangent to the curve at the point P. Now what is the point P? Did they mention it here? They have mentioned that the point P is this one. So this is point P. This one is point P. So P comma 0. That means if P is minus 1, question number D, P is minus 1 comma 0. So we found the point P. Now we have to find the equation of the tangent. So for finding the equation of the tangent, we need to find dy by dx. So y equals to 3 ln 2x plus 3. So therefore dy by dx equals to, so we need to review the formula, the derivative of log. Log means ln is also log. So d by dx of ln ax plus b is going to be reciprocal 1 by ax plus b. So that's it. And remember the chain rule, d by dx of the simple algebra, which is going to be ax plus b. So this is the rule. So this is 3 is going to be there as 3. So ln of 2x plus 3 is going to be 1 by 2x plus 3, the reciprocal, into d by dx of the algebra 2x plus 3 is going to be 2. So this would be 6 divided by 2x plus 3. At p, we know x equals to minus 1. So the gradient is going to be dy by dx 6 divided by 2 into minus 1 plus 3. So this will be plus 3. So this would be 3 minus 2 is 1, so 6. Now you have to find the equation of the tangent. So the gradient rule of C1 says gradient of tangent and gradient of line is the same. Gradient of a tangent line is the same, and the curve and the tangent has the same gradient. So gradient of tangent equals to dy by dx, which is the gradient of the curve. So 6 is the gradient. So now let's find the equation. So equation of tangent y minus y1, which is 0, equals to m, gradient is 6, x minus x1 minus minus plus 1. We can write y equals to 6x plus 6. That's the equation of the tangent.